Before adding an armature to rig the character, first check the origin point of each mesh. That's the small dot the widget focuses on when the mesh is selected. Each needs to be located at the 0, X, Y and Z axis point on the grid. If they are not, position the cursor at the center of the grid using the 3D cursor settings. Then with the mesh selected, in the Tools tab of the tool shelf, click the Set Origin drop-down and select Origin to 3D Cursor. The origin point, if not already at the cursor, will jump there. Repeat for the opposite mesh, select, Tool Shelf, Set Origin to Cursor. This fixes the origin of each mesh to the center of the grid. If there is a gap between the two objects, use the Location in Transform properties to make adjustments and then reset the origin point so both objects occupy the same position on either side of the center line. Once done, both halves of the character will need to be reset so the scale is equal to 1 and uniform. This is done using the Apply setting, Rotate and Scale, which won't work at present because the two meshes are linked. To fix this, the duplicate needs to be made unique. So with it selected, from the Object menu, select Make Single User, Object and Data. Confirm. This breaks the association so both objects can now be reset. Object, Apply, Rotation and Scale. As the mesh was mirrored across the central axis, it will be flipped inside out. So once the rotation and scale has been set for both objects, select the inverted mesh, enter Edit Mode, select all, then in the Tool shelf click the Shading and UVs tab, then the Flip Direction button. This inverts the mesh so it faces outwards. Exit Edit Mode and double check the objects by resetting them again to make sure. This initial prep is important to ensure that the model behaves correctly outside of Blender. If the object's scale is different to its actual size, when exported, the objects appear deformed. Once all of this is done, save an iteration of the file, ready for the next step. With both objects and the 3D cursor now centered on the grid, select View, Front, View, Persp, Ortho. This flattens the view, making it easier to manage and manipulate the armature, which can now be added. So from the Add menu, select Armature, Single Bone, which places an armature object in the 3D view comprising a single bone. Check the armature's initial position, typically directly underneath the character, so flip between right, left and front view to double check. If everything looks okay, save another iteration of the file, creating a restore point. Switch viewport shading to wireframe. Make sure the armature is selected and enter Edit Mode. Right-click the main body of the bone to select the entire element. Then from the Armature menu, select Duplicate. Right-click to release and reset the bone. Then left-click drag the blue handle of the widget, moving the bone to the torso. Exit Edit Mode for the moment, and with the armature still selected, click the Object Data Properties button. Here, under Display, left-click the Names checkbox to activate, turning on the display of bone names in the 3D view. Toggle back into Edit Mode, and then in Bone Properties, the bone names can be changed. Right-click the upper bone if not selected, and in the input field at the top of Bone Properties, type Torso. Press Enter to confirm. Select the lower bone, and in the input field again, type Root. Press Enter to confirm, updating the names displayed in the 3D view. With that done, right-click the top of the torso bone and left-click drag the blue handle of the widget upwards, increasing the bone's size. Bones comprise three components: head, body and tail. Right-clicking the body selects the entire bone, whereas the head and tail can be selected independently. Again, right-click. This allows for the bone to be manipulated as a unit or as a segmented object, which deforms around the unselected element, or the bone itself can be selected and manipulated as a unit. With these initial modifications to the armature done, save a restore point. Continuing on, toggle back into Edit Mode select the torso and then duplicate. Right-click to release, then right-click, hold and drag the bone to the character's shoulder. Left-click to confirm. Right-click, select and drag the tail end of the bone, repositioning it between the arm and leg. Left-click to confirm. The result should orientate the bone to about 45 degrees relative to the torso. Right-click the body of the bone to select, then from Armature menu, duplicate. Right-click to release, then right-click, drag, repositioning it to the top of the upper arm. Left-click to confirm. Right-click, drag the tail end of the bone to the elbow. Left-click to confirm. This elongates the bone following the shape of the arm. With the tail still selected from the Armature menu, click Extrude. A new bone appears with the tail node selected. Reposition this at the wrist and left-click Confirm, again following the general shape of the arm. Then once more with the node active, Armature, Extrude, then drag this new node to the fingertips, left-click to confirm. Once the arm is complete, select each bone in turn and in Bone Properties, assign a unique name. In this instance, that's shoulder, arm upper, arm lower, and hand, each of which is appended .r representing the right side of the character. This will be important later on. Make sure each bone name is unique, as this too is important for a later step. If they are duplicates, Blender will automatically append a numerical increment, best removed to save confusion. Once the names are set, right-click, drag each bone of the arm in turn to check the connection between them. The hand, lower and upper arms should be chained together. The shoulder bone, however, is not part of this chain because it is not linked in any way to the upper arm, which was duplicated from it and not extruded. This needs to be changed. Select the upper arm bone and then in Bone Properties, click the bone icon in the parent input field and from the list select shoulder.r. A line will appear between the two indicating they are now linked but not physically connected. The difference means that whilst connected bones influence other bones along a chain, linked bones can be manipulated independently. With the arm bones now set up, once again select the shoulder and duplicate, Armature, duplicate. Right-click to release, then right-click drag to the top of the leg, left-click to confirm, right-click drag the tail end of the bone down to the knee, left-click to confirm, and then whilst the node is still selected, extrude a new bone, Armature, extrude, position the new tail node at the character's heel, left-click to confirm, then switch to the side view from view, left or right, and extrude the foot bone, positioning the new tail node at the character's toes, left-click to confirm. Switch back to front view, and with the leg bones now available, as was done with the arm bones, rename them in Bone Properties. Right-click to select each bone in turn, and in the Bone Properties input field, assign a new name. In this instance, leg upper, leg lower, and foot. Each again is appended .r. A view change may be necessary to select the foot bone. Check their connection. Right-click, drag to manipulate, right-click again to release and reset, and as with the bone chain for the arm, this checks to make sure the bones are connected, but also similarly needing to be linked to the shoulder bone. So switch to front view, right-click, select the upper leg, and in Bone Properties again, select shoulder from the parent bone list. If the name previously assigned to the shoulder bone has been modified because of Blender automatically appending the unique identifier, reselect and in Bone Properties update the name. Make sure also to check the relationship between the bones, that the upper arm and the upper leg are connected to the shoulder bone. If not, select each in turn and from the parent list select the shoulder bone to reset the association. Once the arm and leg bone chains have been set up and connected to the shoulder bone, save the file and create a new restore point. With the basic structure for the arm and leg in place, they can now be adjusted to better match the shape of the mesh. To adjust the side aspect of the leg, for example, switch to Right Ortho, right-click select each head and tail node in turn, and left-click dragging the directional arrows of the widget, reposition the selections so the overall bone chain follows the shape of the leg. When positioned correctly, there should be a kink at the knee, with the tail node of the lower leg bone placed at the ankle, causing the foot to angle down towards the toes. Once the right side adjustments are made to the leg, check the changes in front view before then switching to top view to make similar adjustments to the arm. That's view front and then view top. Right-click each of the head and tail nodes and reposition them using the widget handles to better follow the shape of the arm. The head node of the upper arm at the shoulder, the tail node of the same bone at the elbow, tail node of the lower arm at the wrist, and the tail node of the hand at the fingertip. Make any minor adjustments. Then select the shoulder bone and reposition this so it aligns approximately with the arm bones from top view. When positioned correctly, it should sit center mass of the shoulder blade of the mesh, again from top view. With all this work now done, switch back into perspective mode, that's view, perspective, and then front, and inspect the armature's progress so far to see how it aligns with the mesh in full 3D mode. If everything is aligned, before continuing, save a restore point. The next section of the armature to add are the bones for the top knot. From the View menu, toggle into Right Orthogonal, right-click select the torso bone, then from the Armature menu, select Duplicate. Reposition the new bone at the base of the top knot. Left-click to confirm. Right-click the tail node and reposition it to correspond to the first loop of edges on the top knot. Left-click to set in place. With the node still selected, from the Armature menu, select Extrude to create a new bone. Drag outwards towards the top of the mesh section, left-click to confirm. Use the bone nodes to tidy up the position of each bone, then select each in turn and in Bone Properties, assign a name, in this instance Top Knot 1 and Top Knot 2. Once done, right-click select the lower of the pair, and in the Relations subpanel, left-click Parent, and from the list of bones available, select Torso, creating a link between the two. Important for animating. Once the bone chain is in place, switch views to check its position, and then save the file. Before moving on to the final aspect of creating the armature, mirroring bones, correct the positions of any bones, making minor adjustments as needed, for instance adjusting the foot and hand bones, making sure they are aligned to the mesh. Generally speaking, it's important to do this before mirroring to ensure that both sides are exactly the same. They need to be duplicates of one another to avoid articulation problems during animation. Adjustments to one side or the other after the fact should be avoided. Once the necessary adjustments are made, in the 3D cursor subsection of View Properties, ensure the X, Y and Z location of the cursor are at 0, centering the cursor itself at grid center. This forms the point across which the selections will be mirrored, so its position is important to make sure that the duplication is exact. Next, shift right-click, select the arm, leg and shoulder bones, and then from the Armature menu, select Duplicate. Right-click to release. In the 3D View header, set the pivot point to Cursor, and then from the Armature menu again, select Mirror X Global. The bones will flip across the pivot point, left-click to confirm and set in place. Once done, save the file. In duplicating the bones, their names have also been duplicated. To address this, whilst the selection is still active, from the Armature menu, select Flip Names. This corrects the problem, making each bone unique, automatically appending .L for bones on the left to match the bones appended .R already on the right. For flip names to work correctly, it's important that the original bones duplicated are already appended .R or .L depending upon which side of the armature they're on. If this is not done, flip names will likely not work as it should. With the armature mirrored, save the file. With the armature complete, the next stage is to set up vertex groups. Switch edit mode from the armature to the mesh. Change the selection type to vertex, then from the select menu, deselect any active selections, clearing the mesh. To create vertex groups, first click on the Object Data Properties button to access the Vertex Groups panel. Then in the 3D view, hold Ctrl and left-click drag an area of the mesh, creating a lasso selection. In this instance, the character's right hand. In the Vertex Groups subsection, left-click the plus button to add a group, double-click the name and type hand.r. That's hand right. To assign the group to the vertex selection, click the Assign button, then Test with Select and Deselect. Press Ctrl, lasso select the wrist vertices up to the elbow. Create a new vertex group. Double-click to rename, type arm lower.r, press enter or left-click to confirm. Assign and deselect. Shift right-click select the upper arm vertices. Add to the selection with Ctrl left-click to loop select the vertexes at the elbow. Create a new group and rename arm upper.r. Assign and deselect. Once groups are established, the vertex groups list can be used to reselect areas of the mesh. Simply highlight an entry and click the Select button. Continuing on, reposition the scene. Ctrl left-click drag loop select the foot up to the lower ankle vertexes. Create a new group. Double-click, rename foot.r. Assign, then deselect. Lasso select the lower leg, that's from the lower ankle to the knee. Create a new vertex group. Double click, rename leg lower.r. Assign, then deselect. If selecting vertexes is tricky in wireframe mode, switch to a different viewport shading and then make the selection. Returning to wireframe to continue. Select the upper leg vertexes, then lasso select the knee. Create a new group in the Vertex Groups list. Double click, rename leg upper R, assign, and then deselect. Before moving on, use the Vertex Groups list again to check the assignments are clearly defined. To define the shoulder group, use Shift right-click to select the upper arm vertexes, the upper leg vertexes, and the vertices of the shoulder where it joins the torso. Create a new vertex group, double-click, and rename shoulder.r. Click Assign, and then deselect. To view all the groups created so far, move the mouse over the bottom of the list. When the double-headed arrow appears, left-click drag, expanding the aperture. Continuing on, reposition the scene so the top knot is visible, and select the vertices at the join between the top knot and the head and the next loop up. Create another vertex group, double-click and rename top knot 1, assign, and then deselect. Then loop select the remainder of the top knot, create another group, double-click, rename top knot 2, assign, and deselect. The final group to define is the torso to which the remainder of the mesh will be assigned. Rather than trying to select the remainder of the mesh with other elements already established, using the Vertex Groups list, highlight each in turn and click Select. Once done, from the Select menu in the 3D view, select Invert. This inverts the previous selections, highlighting the remainder of the mesh. Using Shift right-click, select any stray vertices, switching display mode where necessary to complete the selection, which should also include the underside of the character and the top knot, where it joins the back of the head. Once the entirety of the torso is selected, create a new group, double-click, and rename this Torso. Click Assign, then deselect. Once this is done, save the file. Once the vertex groups have been created, the next step of the process is to link the armature with the mesh. At the moment there is no association between the two, so manipulating the skeleton has absolutely no effect on the mesh. This can be tested by quickly switching to pose mode, manipulating individual bones to see if they influence the mesh. At this point they shouldn't. So before returning back, clear any rotations that have been made. That's select and deselect all, then pose, clear transform. Switch back to object mode, then select the mesh, and from modifier properties, left click add modifier, and from the deform column, select armature. A set of properties will appear. Left click the object input field and select armature from the pop-up list. This links the armature object, called armature, with the mesh. So on returning to pose mode, to once again test the rig, manipulating bones now influence the mesh. Again, when done testing, clear and reset the armature. Select, deselect, and then pose, clear transform, all. If the armature has been manipulated in any way, it is important this is done before continuing. Once reset, save another restore point. With the right hand side of the character set up with vertex groups and the armature modifier, this needs to be replicated on the left hand side of the character. So right click select the mesh, enter edit mode, clear any previous selections where necessary, and begin creating the groups. Lasso select the hand, create a new vertex group, double click the entry and rename hand.l, assign, deselect, and continue on. Lasso select the lower arm, create a new group, double click, rename arm lower.l, assign, deselect. Switch display mode to aid vertex selection of the upper arm. Switch back to wireframe and lasso select the elbow. Create a new group, double click, rename arm upper.l, assign, deselect. Check the groups, select each listing, and then deselect, and then continue on. Lasso select the foot, create a new group, rename foot.l, assign, deselect. Lasso the lower leg from ankle to knee, new group, rename leg lower.l, assign, deselect. Switch display mode again to aid selection of the upper leg vertices. That's the edge loop at the very top of the leg. Then switch back to wireframe and select the knee. Create a new group, rename leg upper.l, assign, deselect. Check the groups once more and continue. Select the shoulder. Again, switch display mode to make selection easier. Select the vertices at the top of the leg, top of the arm, where the shoulder joins the torso. Switch back to wireframe. Create a new group, double click, rename shoulder.l, assign, deselect. For the top knot, make the selection, create a new group, renaming top knot 1, duplicating the other half of the mesh because both sections are articulated by the same bone. Lasso select the remainder of the top knot, create a new group, similarly rename top knot 2, again replicating the other half of the mesh for similar reasons. It's articulated by the same bone. Select all the groups just created, highlighting the respective areas of the mesh. And from the Select menu, select Invert. Right-click, select any remaining vertexes, ostensibly where the top knot joins the back of the head and where the shoulder joins the main body. Create a new group, rename Torso. Again, as with the top knot, the torso vertex group is manipulated by the same bone controlling the other half of the character. Assign and then deselect. Once done, press Tab to exit edit mode and check the assignments by selecting the armature, switching to pose mode and then manipulating the leg bone to see how the mesh moves. At this point, however, the mesh will not move with the bone because there is no connection between the two. Exit pose mode, select the mesh, and in Modifier Properties, assign an Armature modifier, selecting the armature as the object linked. Selecting the armature now and returning back to pose mode, on manipulating any of the bones, the mesh will articulate. After testing the bones and their articulation of the mesh, before moving on, make sure to clear any bone poses. Select all the bones, pose, clear transform, all. And this will reset all the bones to their default positions. Check the file once over and then save a version. Now, due to the way the armature was built in sections, that's an arm section, leg section, torso and so on, the armature's overall hierarchy ends at the terminal bone of each section, the thigh bone, shoulder bone, and so on. To address this, the relationships need to be modified to link everything together. This ensures when the limbs are manipulated, they move in relation to the overall character and not just the segment to which they belong. Exit pose mode and enter edit mode. Access bone properties. Select the bone to be modified, in this instance torso, and from the parent drop-down list, select the bone to be connected to, in this instance root. A short dashed line will appear between the two, indicating a connection. To test, go back into pose mode select the root bone, and when moved, the torso bone will move with it. Continuing on, go back into edit mode, select the shoulder bone, shoulder.r, and in bone properties again, click parent and select torso from the list. Checking this in pose mode will now also move the right side of the armature. Return to edit mode and select shoulder.l, that's the left side. Click parent and select torso from the list. Checking this in pose mode, with torso now selected and moved, the entire armature will move. The same also holds true for root because of its connection to torso. Once this is done, save the file, creating another restore point. With the bone relationships now fully established, the final step is to add an inverse kinematic to specific bones of the armature to assist their articulation. In pose mode, select foot.l, then in bone constraints, select inverse kinematics. By default, this has control over the entire skeleton. To change this, alter the chain length setting. 1 controls the original bone, 2 controls that bone plus the one above, and 3 will control the entire leg. Repeat the process for foot.r, select, in bone constraints, add an inverse kinematic, set the chain length to 3. Once the feet have been set up with an inverse kinematic, the property also needs to be assigned to the character's hands. Select hand.l and in bone constraints, assign an inverse kinematic. To override the default control over the entire armature, set the chain length to 3, terminating the chain at the shoulder. Repeat the process for hand.r, select the bone, and in bone constraints add an inverse kinematic, set the chain length to 3, again terminating at the shoulder. Save the file and create another restore point. A final but optional inverse kinematic can also be assigned to the top knot, so select the bone, bone constraints, inverse kinematic, and set the bone chain to 2. This prevents the IK from including the torso bone, which would then mean the top knot controlling the entire armature. Once done, save the file. The very last step of the process is to join the two halves of the mesh together. Shift right-click both in object mode, and from the object menu, select Join. Switch to edit mode, and then select the entire mesh, and in the tools shelf, scroll down to and click on Remove Doubles. This unifies the mesh by removing the seam running down the center. Switch to texture mode, and test. Select the armature, in particular the bones assigned the inverse kinematics, manipulating each in turn, making sure both armature and mesh deform properly. If the individual bones are difficult to see and select, in Object Data Properties, enable X-ray to view the skeleton through the mesh. Then once done, save the final version, completing the rigging process of the character.